Who gives a higher real estate assessment? In an experiment, a single home was assessed by both real estate appraisers and local government tax assessors. A randomly selected sample of 22 appraisers done by the real estate appraisers had an average value in thousands of 212.1 with a standard deviation of 8.48. A randomly selected sample of 23 appraisals done by tax assessors had an average of 225.3 with a standard deviation of 9.01. Find the 90% confidence interval for the true mean difference between the two types of appraisals. Okay, so they're clearly asking us to find the 90% confidence interval, so it's a confidence interval. We're looking for the true mean difference between the two appraisals. They then tell us to assume equal variances. That's an indication that it's going to be a t-interval, and that's probably because our sample sizes are small. And yes, we see that the sample sizes are 22 and 23 respectively. Now, they tell us the mean and the standard deviations. Let's identify those for both groups. And then they give us our confidence level. So we have everything we need to do our confidence interval. So let's start with our very first step for the confidence interval, and that is to record all the data, right? So let's write all the data down that we have in a useful way. All right, so let's start with the appraisals done by real estate appraisers. So we'll use that as A for appraisers, or AP for appraisers. And the other one we'll do the tax assessors, so we'll use that as TA for tax assessors, right? So we'll have two different groups here. For the appraisers, we'll have an N, we'll have a sample mean, we'll have a standard deviation. For the tax appraisers, we'll have an N, we'll have a sample mean, and we'll have a standard deviation. Okay, so let's start with the N for this group. It's 22. The mean was 212.1. The standard deviation was 8.48. For the other group, the number was 23. The mean was 225.3 or 225.3, and the standard deviation is 9.01. Remember, these are in thousands of dollars, right? Okay, now we have the confidence interval. So the confidence level will be 90%, and therefore alpha will be 0.10. And of course, we'll be using alpha divided by 2 because it's a confidence interval, and we'll use that to go to our table. Now, the next step is always to go to our table and get a table value. Here we will be using a t alpha divided by 2 value, right? And the degrees of freedom for that value is going to be n1 plus n2 minus 2. So let's work out what that would be. Alpha divided by 2 is going to be 0.05, and we'll be looking that up in, if we look at this, it's minus 2, so we can call that 20 plus 23 is 43. So our degrees of freedom will be 43 for this. So let's go to our t-table, look up under the 0.05 column, 43 degrees of freedom, and let's get our critical value. Okay, so we're looking at the area in one tail of 0.05. We're going to go down till we see 43 degrees of freedom. 43 degrees of freedom. Okay, so let's scroll down until we see that. Now, what you're going to see here is that the answer is somewhere between these two values, right? That's the value for 40, and that's the value for 45. Well, 43 is in between. You may say, well, the degrees of freedom 43 is closer to 45, but you'll notice that the number for 40 is actually larger, and that makes our answer more conservative, and that's going to be a safer result then. So what I want you to do every time you encounter this, whenever you're in between two values, you want to take the one that's larger. So in other words, even though 43 is closer to 45, we'll choose degrees of freedom 40 as our answer. So we're going to use 1.684 as our critical value. 1.684. Okay, so we found the table value 1.684. All right, now that we have that value, let's go ahead and take that and plug it into our margin of error formula. Our margin of error formula is going to be E is equal to T alpha divided by 2 times the square root of SP squared over N1 plus SP squared over N2. Remember, it's SP because we're dealing with a pooled estimator, and this comes from the statement in the problem that said, assume equal variances. So when we look back at our problem, we see that they said in the problem, assume equal variances. Because they asked us to assume equal variances, we're going to use the pooled estimator, SP squared. That has to be calculated, so we have to stop here for a second and go calculate that. So SP squared, the pooled sample estimator. Now, remember, this is the pooled estimator of the standard error for our estimator x bar 1 minus x bar 2. So this is what we're trying to do. And it's basically a weighted average of the variances that we would get by squaring these guys. So let's take our n1, which is going to be n1 minus 1 times s1 squared plus n2 minus 1 times our s2 squared. And then we'll do, for the bottom part of that, the degrees of freedom we had down here, which is just n, or basically the sum of these two degrees of freedom. So n1 plus n2 minus 2. All right, now let's plug in the number. So n1 minus 1 is 21, right? Times this guy squared, that's going to be 8.48 squared, 8.48 squared, plus n2 minus 1, which is going to give us 22, times its standard deviation squared, 9.01 squared. All that divided by that 43 that we came up with before. Okay, so let's work that out in our calculator and see what that actually gives us. So we take our calculator, we can do 21 times 8.48 squared plus 22 times 9.01 squared. All right, so that's our top part of the fraction, and we end up with 3,296 basically divided by 43. When we do that, we get 76.653 ... right? Okay, so let's take that now and plug that in here in our formula. Okay, so remember our answer here was 76.65 ... We'll just write on and on and on. Okay, now let's take that and plug it into here finally to get our margin of error. All right, so our t table value is 1.684. That'll be times the square root of this 76.65 number. Notice it's already squared, so we don't have to square it or anything. We just plug it in as is, right? So ... I'm going to store that in my calculator so we can use it directly, right? So I'm just going to write ... But of course, when I put it in the calculator, I'll be putting the full value in. The sample size is 22 plus this value again, so 76.65 ... divided by the sample size 23. Okay, so let's work that out and see what we get. Okay, so again, I've already stored my 76.65 number into my variable x in my calculator to make my calculation a little easier. And then I'm just going to do 1.684 times the square root of, then that's in my calculator is x divided by 22 plus x divided by 23. Close that up, hit enter. I get 4.3968, etc., right? 4.3968, ... So my margin of error basically becomes 4.3968, ... So again, I'm going to store that in my calculator so I have it for use for later, right? For my next step, my last and final step. So that's my margin of error. I'm just going to put it in my calculator as a variable x, right? So I store it in the calculator. It's now ready for use later. Okay, so let's finish this problem by doing the very last step, which is basically just to do that subtraction and addition problem that's required to finish or complete the interval. So let me go ahead and move this paper out of the way and we'll put a new sheet down. Okay, so taking what was important from the problem we just worked out, let's look at what that gives us. All right, so we'll have x bar for the appraisal group, real estate appraisers group, to be 212.1, and the x bar from the tax group, tax appraisers group, being 225.3, 225.3. All right, so what we want to do first then is to subtract those two numbers so that we come up with the first part of our interval, which is going to be, x for the appraisers minus x bar, for the tax appraisers, right? Then we'll do minus the error. Then we're going to have, again, x bar for the appraisers minus x bar for the tax appraisers plus the error. And when I'm done, that will give me the interval. Okay, so let's get that difference first between the two appraisals. So 212.1 minus 225.3, we're going to get the answer negative 13.2. So negative 13.2, negative 13.2. And then we'll do minus the error plus the error. And that will give us our final solution. All right, and then from there, if we actually plug in what the error is, which I already have stored in my calculator, so negative 13.2 minus the error, which I've stored as x, I get the answer negative 17.6, let's say. And if I do that again, this time putting a plus sign, I get the answer minus 8.8, minus 8.8. Okay, so this is where we believe the true mean difference to be for these two variables, right? So we believe the true mean difference is between those two values. The fact that there is an interval that's both negative here, and since we did the subtraction, basically the appraisers minus the tax appraisers, right? So the real estate appraisers minus the tax appraisers estimates, what we realize is that if the second one was bigger, if this one was larger, the interval would become negative, because if he's larger, we subtract from this value, we'll end up getting negative values here in the interval. And so the fact that both of them are negative means we have a significant negative difference here, which essentially means that the tax appraisers' appraisals are significantly larger than the real estate appraisers. So basically, if you get a tax appraiser to come to your house and appraise your house value, it'll end up being higher than the real estate appraiser's value. Of course, which has consequences, because the tax appraiser is going to base your taxes on that appraisal, right? So the fact that their appraisals are higher, that's important. But either way, if the question asked at the end, like ours did, is there a significant difference between the two groups? Remember, our question asked that, is there a significant difference between the two groups? Our answer for that is yes, there is. Okay, so there is a significant difference between the appraisals provided by real estate appraisers and tax appraisers.